Okay, so in this lesson we're going to be looking at how to rewrite formulas, and it's really important that we understand some basic algebra concepts. That's why we spent the time on the previous lesson about learning how to solve some different types of equations, because the skills, the methods that we used in those lessons are really going to be helpful with this one, with rewriting formulas. Now, what's the point? Why do we even have to bother knowing how to rewrite formulas? Well, what this first paragraph is talking about is, let's say if we have a situation where we know the formula for the volume of a cylinder that they give us there, where the volume is pi times the radius squared times the height. But we use that formula when we know the radius and we know the height of a cylinder, and we use that to figure out the volume. But what if we have a situation like, let's say, if you think of a Red Bull can. Red Bull, when they came out, they wanted to make themselves different. They wanted to separate themselves from just a cola. They wanted to make sure that people recognized that they were set apart. There was something different. And there's 12 ounces in a Red Bull can. There's 12 ounces of cola in a regular pop can. But you know the two cans are completely different. They're both cylinders, but they're different shapes, or different heights, I should say. So chances are what probably happened is there was someone working there that said, well, we know that the volume is going to be 12 ounces. We want to mess around with some different radiuses for the can and figure out how that would affect the height, because they have to consider shipping and what kind of boxes these cans are going to go into. So they probably played around with some different radiuses and figured out, like I said, to figure out different heights. Well, you're not going to want to use the formula for the volume of a cylinder to try to do that, because if you know the volume, and let's say you know the radius and you're trying to find the height, well, that's going to be a pain to try to redo all that algebra to figure out what the height is each time. So it's more beneficial in this scenario to get the h by itself. Now we call that solving for h. And that's what we're doing in this first example. So let's look at it. And again, I can't take the credit nor the blame for these cheesy names. These are from the textbooks. Let's look at it. It says, Justin Case is an engineer for a barrel manufacturing company. He wants to design a cylindrical barrel to contain 500 cubic centimeters of liquid and is considering several different radii and heights. To do this, it is useful to solve the volume formula for H in terms of R and V. That got taken off there by accident, but it's in terms of R and V. Now let's make sure that we understand what they're asking us for here. Because remember, again, I keep mentioning that in math, part of the problem is just making sure you know what they're even asking for, because sometimes the way the question is phrased, you don't even know how to get started. So getting started is half the problem. So this one here, it says, solve for H in terms of V and R. Whenever you see that first phrase, solve for H, that's the variable that you want to get by itself. Right now, this formula is solved for V, because the V is by itself. So this volume, or this formula for the volume of a cylinder, we would say it's already solved for V in terms of R and H. Well, we want to change it so it's in terms of V and R. What that means is I want to make it so that the variables that I'd be using to plug information into to figure out the height, that they're together already on one side of the equal sign. So, but whenever you see this phrase for H, that means, or for whatever variable, that means that we want to get that variable by itself. So now I know my goal. I know my goal is to get my equation, my formula, to say H equals something. Well, let's look back at the original formula. And again, my goal is to get the H by itself. So I have pi times the radius squared times the height. Remember in algebra, to get rid of something, we always do the opposite. So the opposite of multiplying pi times the radius squared times the height would be divide pi r squared. So if I want to get the h by itself, I'm going to divide pi r squared at the same time on both sides. Because we can do both at the same time. Sometimes we get in the habit of just doing one thing at a time. Well, in algebra, we need to be familiar with and comfortable with multitasking, meaning we want to sometimes divide more than one item at a time. And this is just one of those times. We're going to divide by pi r squared. So now when I do that, I get the h by itself, which is my goal, equals v divided by pi r squared. And the people that worked for Red Bull, this would have been the same formula they would have used. They would have put 12 ounces in here, and they would put different radiuses. to figure out the height of the Red Bull can. And actually that's what we're going to do in part B here, except for we're dealing with these barrels. We want to figure out what the height of a barrel would be with a radius of 30 centimeters. That would be containing the 500,000 cubic centimeters of liquid. So the height would equal 500,000 divided by pi times 30 squared. Now this is a good time to talk about our calculators, because if I just type this in, if I just typed in 500,000 divided by pi, pi is down here next to your h, so it'd be pi, you could just hit enter, times 30 squared. This is actually the wrong way to do it. You'll see why in a second. Here's my answer. Now, not only should the answer tell you that something's wrong, but you should also look here where it says, because the nice thing about the cast is after you hit enter, it shows you what it just computed. If you notice it had 500,000 divided by pi, they're doing that first, and then multiplying that answer times 30 squared. Well, if you don't have a cast, what you're going to have to do is the part that we're dividing by, that goes in the denominator, you'd want to put parentheses around that. But the nice thing is if we have a cast, what we can do is this. If you hit the control divide button, you get this fraction bar. Now we can type in what goes in the numerator, 500,000, arrow down to get to the denominator. The pi, again, is next to the h, so it'll be pi, hit enter, times 30 squared. Now when I hit enter, we see we get two completely different answers. For this one, I get 176.8 centimeters would be the height of the can. For the first one, we had 143 million centimeters would be the height of the can, which obviously wouldn't make sense. So for one, when we're solving story problems, make sure your answer makes sense. And for two, always check over here to make sure that what you've typed in is what the calculator computed is actually what you want it to do. Oops, so it was 176.8, we'll say, centimeters. Okay. Now that one wasn't so bad as far as getting the variable by itself. This one, they ask us to solve this formula, P equals 2 pi times the square root of L divided by G. They ask us to solve for L for this one. But if you notice, my L is trapped underneath the radical. We can't do anything with this L yet. Okay, we can't do anything with that because of that radical sign. Now, what I want to do first, the best way to approach this problem is to get the square root by itself. Okay, don't worry about the fact that there's a square root in there. We're going to save that for later. Remember what we just talked about? We have 2 times pi times the square root. We can multitask. We can divide by two things here. We're going to divide by 2 pi. So I get P divided by 2 pi equals the square root of L divided by G. Now, at this point, this is where we want to get rid of the square root. Remember in algebra, I said this a minute ago. In order to get rid of something in algebra, we always do the opposite. So to get rid of the square root sign, we do the opposite of square rooting is squaring something. So I'm going to square both sides. So by squaring both sides, it gets rid of that radical. So I'm left with the L and the G by itself on the right side. Now on the left side, everything gets squared. The P gets squared, the 2 gets squared, so we can say that's 4, and the pi gets squared. And now we want to get the G by itself. So we can multiply both sides by G. So my equation would be L equals G times P squared divided by 4 pi squared. That would be your answer. So now for this next problem, when it says what is the approximate length of a pendulum whose period is 1 minute, you want to be careful first off. Notice how this says that the period of the pendulum, remember the period is how long it takes for the pendulum to swing back and forth. I guess I didn't read the story problem, but you could have gotten that from reading the story problem. But it says a period is the time in seconds that it takes a pendulum to make one complete swing. So notice how this is in minutes, so we need to make sure that we recognize that this is 60 seconds. So now we can plug that in for the capital P. Our G is 9.8 meters per second squared. But all we care about is a 9.8, so it's going to be the length of the string would be 9.8 times your P, which is 60 squared, divided by 4 pi squared. Again, if we're going to do this in our calculators, the way that you could do this is type in 9.8 times, do the control and divide, and it was 60 squared divided by 4 pi squared. 4 pi squared, and enter. We get about 894 meters. And again, you might think, well, 894 meters, that seems kind of long, but remember, this is a pendulum, and it takes 1 complete minute to swing from where it started, to swing back and forth back to where it started from. So it's got to be a pretty long swing, a long string, for it to take that long. So your answer would be 894. Okay. Let's look at one last example. This example, at least for this part of the video, says it takes C equals 65t, all divided by r minus 65. It says to solve the formula for t in terms of C and r. So what that means, remember, is we want to get the t by itself. Now again, we're looking at some different problems. You might wonder, well, how do I get the t by itself? Just remember what we were doing in the last lessons. Remember, we saw equations like this where we had fractions, and we solve these as proportions. C is the same as C over 1. So we can cross multiply. Now to cross multiply the C times r minus 65, here's how you write it. C times r minus 65. 65t times 1, that's obviously 65t. Now you don't really have to distribute the C. We can leave that alone because our goal is to get the t by itself. So I'm going to divide both sides by 65. So our equation would be t equals C times r minus 65, all divided by 65. Okay, why don't you do that with this next example? Why don't you try this one on your own? We're going to change it up a little bit. So we're going to say we're going to solve for S in terms of t and d. So why don't you guys pause the video, try that for this equation, and then hit play when you're ready to check your answers. Okay, so you should have had a chance now to try this out. So let's see what you should have gotten. Again, our goal is to get the s by itself, so I'm going to cross multiply. So it'd be t times d plus 30 equals, again, we're going to set that up as t over 1, so 30s times 1 would be 30s. Trying to get the s by itself, we would divide both sides by 30. The answer would be t times d plus 30, divided by 30. That would be your answer for this problem. Remember, we did change it. If it had been set up the way it was originally, you would have still started it out the same, but then you would have had to distribute the t through, and then we'd have to do a little bit of work after that. But at least for this problem, we'll keep it simple, and we'll leave it as this. Okay. Well, that's enough time that I have to fit on this particular video because I'm limited to 15 minutes. So watch the next video to see how to do these last couple of problems.